Hello and welcome to Schrodinger's cat. Myself Devrata. So today I will teach you the topic named binomial theorem. And in a previous lecture we had discussed the complex number, and we will do the chapter summary in a nutshell and previous year problems so that you can increase your problem solving skills and know how to approach this problem. And I think after doing these problems you will be able to do all types of problems coming in JEE Main and Advanced. So let's get started. So in this topic we'll discuss the chapters the binomial expression and the general term, properties of binomial, and the total number of questions coming in the previous year exam like JEE Main from this topic. There are 2 questions are coming, and in the JEE Advanced the one or 2 questions are coming from this chapter. So first of all, that in this chapter that binomial theorem for positive integer index n, it states that x plus a to the power n, that is equal to nc0 x to the power n plus nc1 x to the power n minus 1 a plus nc2 x to the power n minus 2 a square plus plus, this is the general term ncr x to the power n minus r a to the power r plus plus last term ncn a to the power n. This is the expression for the positive integer indexed n of the binomial theorem. Next one, that for the x minus a to the power n, that is given in the form x to the power n minus nc1 x to the power n minus 1 a plus nc2 x to the power n minus 2 a square plus plus the general term minus 1 to the power r nc1 x to the power n minus r a to the power r plus plus last term minus 1 to the power n a to the power n. So if a is equal to 1 in the expression of a plus x to the power n, that a equal to 1, this is the special case, so it would become 1 plus x to the power n, that is equal to nc0 plus nc1 x plus nc2 x square plus the general term ncr x to the power plus the last term ncn x to the power n. Next one, the properties of the binomial theorem. The properties, first one, that general term in the expansion of x plus a to the power n, that t r plus 1 is equal to ncr x to the power n minus r a to the power r. This is the general term in the expansion of, this is the general term of the expansion of x plus a to the power n. Next one, the middle term. This is the general term. Next one, the middle term. So in the middle term of x plus a to the power n, there are 2 cases. First of all, if n is even, then the expansion has one middle term, that is the n by 2 plus 1th term. So this would become the t n by 2 plus 1 is equal to nc n by 2 x to the power n by 2 a to the power n by 2. This is the middle term when n is even of the n by 2 plus 1th term. Next, when n is odd. So for n is odd, then two middle term for n is odd. That so first of one, n plus 1 by 2 term, and the another one n plus 1 by 2 plus 1th term. This is the two term. So first of one, that t n plus 1 by 2, that is equal to nc n minus 1 by 2 x to the power n plus 1 by 2 a to the power n minus 1 by 2. And the next one, the t for n plus 1 divided by 2 plus 1th, so equal to nc n plus 1 by 2 x to the power n minus 1 by 2 a to the power n plus 1 by 2. Next, greatest term in the expansion of x plus a to the power n. This is the greatest term. Greatest term. So if n plus 1 divided by x by a plus 1 is an integer that belongs to z plus minus, two greatest term, that one is mth and another one m plus 1th. Next, if the m equal to n plus 1 divided by x by a plus 1 is not an integer that does not belongs to z, so one term here, one term is k plus 1th when that k equal to m. Next, the properties. So next one, that are the properties. So first of one, this is the important properties. So 1 plus x to the power n 1 plus nc1 x plus nc2 x square plus dot dot plus ncr x to the power r plus the last term ncn x to the power n. So putting x equal to 1, so it become c0 c1 c2 plus dot 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 cn. This is the 2 to the power n. Very important property. Next, for x equal to minus 1. So for x equal to minus 1, that c0 c2 c4, this is the even one, plus dot dot is equal to c1 plus c3 plus c5 plus dot dot. This is the even one and right hand side is the odd one. And I just give you one important thing, that here C means the combination. We had discussed we'll discuss in the next chapter that the permutation combination. C means the combination, NCR. So this property belongs to that C0 plus C2 plus C4 plus dot 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 equal to C1 plus C3 plus C5. This is the even one, belongs to basically 2n. This is the odd one, belongs to 2n plus minus 1 plus dot dot dot. This is equal to, this is the 2 to the power n minus 1. This is the 2 to the power n, here 2 to the power n minus 1. Next, binomial theorem for any index. That the binomial theorem for any index, that 1 plus x to the power n is equal to 1 plus any index mean, n means 1, half, 2, 2 by 3, this type of rational or irrational. Nx plus nc2 means n into n minus 1 by 2 factorial x square plus dot dot general term NCR means n into n minus 1 n minus r plus 1 by r factorial x to the power r plus dot dot. This is binomial expansion for any index. This is for any index. And next one, n could be anything, positive, negative or fraction. So for 1 plus x whole to the power minus n, so it would become what? 1 minus nx, minus plus, repeat, that n into n plus 1 by 2 factorial x square minus n into n plus 1 n plus 2 divided by 3 factorial x cube plus dot dot dot. And another one, this is for the 1 minus x to the power minus n, that 1 minus x to the power minus n, this is for minus, so here all the terms should be positive, that 1 plus nx, just put this equation number 7 for any index, 1 plus nx plus n into n plus 1 divided by 2 factorial x square plus n into n plus 1 n plus 2 divided by 3 factorial x cube plus dot dot. Next, the general term. General term of what? 1 plus x to the power minus n, that tr plus 1. This is the general term, that tr plus 1 equal to minus 1 to the power r n into n plus 1 into n plus 2 dot dot, last term would be what? N plus r minus 1 divided by r factorial into x to the power r. This is the general term. And next, general term for 1 minus x to the power minus n. Here would be tr plus 1. Here would be what? Here 1 minus 1 to the power r for odd or even. Here would be only n into n plus 1 n plus 2 dot dot n plus r minus 1 divided by r factorial x to the power r. Next, some useful expansion, that very important. One is for integration and next one for the differentiation. So I just write first the integration I, that the c0 x plus c1 x square by 2 plus c2 x cube by 3 plus dot 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 plus cn x to the power n plus 1 divided by n plus 1 with the denominator is equal to integration 0 to x 1 plus t to the power n dt. Here t be the variable. 1 plus t to the power n dt. Next one for the differentiation b, that summation r0 to n r into r minus 1 into r minus 2 dot dot r minus k plus 1 into cr x to the power r minus k, that is equal to dk dxk 1 plus x to the power n. I say one thing, that here the pronunciation would be ddx, not d by dx. Basically ddx is operator defined as capital D. So you just pronounce here dk dx to the power k, or d square dx square, or d2 dx2, not pronounce d by dx, only ddx. This is two important formula. One is the integrate and the differentiate. This would be very helpful for your JEE Advanced previous year questions. We just switched our lecture in a problem discussion session. First one is coming for the JEE Advanced 2024 recent type of questions. Says that let us 1 plus b root 2 such that ab belongs to z, and the t1 that minus 1 plus root 2 to the power n, where n belongs to natural number, and the t2 is 1 plus root 2 to the power n, n belongs to n, then which one of the following statement each or are true. This is a MSQ type questions, means multiple select questions. One or many answers, one or more than one should be correct, and there is no partial marking. Suppose the answer would be 2, B or C, and you have put the answer only B. You have not get any partial marking, just get big 0. Be serious on the topics and the problems. Just so by applying the expansion, we just apply here the expansion, that first of one is given that the minus 1 plus root 2 to the power n is equal to a1 plus root 2 b1, that a1 and b1 belongs to integer, and for 1 plus root 2 to the power n is equal to a2 plus root 2 b2, where a2 b2 belongs to z. So these two imply that z union t1 union t2 is a subset of S, because suppose this is a t1 and this is a t2, and z, this is the whole, and S is a element of this. So this is a subset of S, but b root 2 belongs to S, for negative b belongs to z, that z union t1 union t2 belongs to S. So basically here A option, that z union t1 union t2 is a, this is a subset of S. So first of one we just calculate this is a proper subset, but negative, for negative b this is not hold. So this should be the proper subset of S, not in the subset. Check second option. You have to check all the options and do this problem. Give this answer. So this is the root 2 minus 1 to the power n. It imply 0 less than root 2 minus 1 less than 1. So for greatest value of n, so for this is a combination of the set relation function and the binomial theorem. Combination miscellaneous type questions. So I just keep for solving. So for greatest integer value, that root 2 minus 1 to the power n towards the 0. Therefore, P1 intersection 0 the option 1 by 2024. This is not belongs to phi. Phi is a null set or phi denotes the empty set. This is not belongs. Now check this is check of option A. This is check of option B. Now check option C. That 1 plus root 2 to the power n. That imply root 2 plus 1 is greater than 1 such that 1 plus root 2 to the power n tends to infinity. So T2 intersection infinity, so 2024 comma infinity, that is not equal to phi. Now check option D. Option D is what? The cos, this term, the cosine of pi into a plus b root 2, that is equal to 0, is imply that AB belongs to integer and b equal to 0. So first option is correct, A. We have manipulated here. Second one is not correct because this is not empty. And third one, T2 intersection 2024 infinity, that does not equal to phi. This is also correct, C. And for D, for any given AB belongs to Z, cos pi into a plus b root 2 plus I sin pi into a plus b root 2, if and only b equal to 0. This already hold because suppose I just here I just give you the real part of the cos, and for the imaginary part, that is the I sin of the sine of pi a plus b root 2, that is equal to 0. So AB belongs to Z if and only that b equal to 0. So D would be a correct answer. So here A, C and the D, A, C, D option are the correct. Next one, recent questions, JEE Main 2024 says that x square, the coefficient of x to the power 70 in x square 1 plus x to the power 98 in this expansion, that is equal to 99 Cp minus 46 Cq, then the possible values of p plus q. So I first write the expansion here, that is given. So x square 1 plus x 98 plus x cube 1 plus x to the power 97 plus x to the power 4, that is 1 plus x to the power 96 plus dot 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 plus x to the power 54 1 plus x to the power 46. So this is equal to what? That x into 1 plus x just is in the binomial form, that would be 98 C 68, 97 C 63. By the properties I just write here, the properties of the general term. I just write by this term that tr plus 1, I just write here the general term tr plus 1 ncr x to the power n minus r a to the power r. So next 96 c66 plus dot 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 plus 47 c17 plus 46 c16. So it would become 46 c30 plus 47 c30 plus dot 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 plus 98 c30. We just apply the term that Tn plus 1 by 2 equal to Nc n minus 1 by 2 x to the power n plus 1 by 2 a to the power n minus 1 by 2. I just write in your chapter summary class that if n is odd and even, what is the middle term? So now just combine 46 c31 plus 46 c30 1 47 c30 plus dot dot plus 98 c30 minus 46 c31. This would be what? 47 c31 47 c30 plus dot dot the last element 98 c30 minus 46 c31. This would be what? 99 c31 minus 46 c31. This is equal to 99 cq minus 46. This would be the cp given in the equation is given that 46 cq. This is given given 99 cp minus 46 cq. So the possible value of p plus q would be what? The possible values are 62 and the 83. So here given 62 is not given in the option, so 83 would be our answer, that p plus q is equal to 83. C would be our correct answer. Go ahead. Next question. Question number 3 is coming. JEE Main 2023 is saying that suppose summation r0 to 2023 r square into 2023 cr is equal to 2023 into alpha into 2 to the power 2022. Then what is the value of the alpha? This is the questions NAT, numerical answer type questions. You have to just write the integer digit in the box. So this is the given. So we have discussed in your chapter summary one important result, that summation r0 to n r square into ncr, that is equal to n into n plus 1 2 to the power n minus 2. So this is the derived equation. So r square 2023 cr is equal to 2023 into 2024 into 2 to the power 2021 by this equation 1. So this would be what? 2023 into 2024, I just write 2021 into 2 divided by 2. Just to multiply with the numerator and the divide with the denominator. So this would be what? 2023 for this form is given into 2024 by 2 means 1012 into 1 plus 2021, this would be 2022. Just compare with the equation. This is the equation number 1a, that given 20 23 into alpha into 2 to the power 20 22, that implies that alpha would become 1012. So 1012 would be our answer. The alpha is 1012. Next, question number 4. This is also another recent questions. JEE Main 2022. That summation r 1 to 20 r square plus 1 into r factorial is equal to what? This is the calculation type of questions. Just calculate with analytically that summation r equal to 1 to 20 r square plus 1 into r factorial. This would be what? So this is the sum. R square plus 1 means r plus 1 whole square minus 2r. This is the formula. Into r factorial as it is. Next, I just split the whole square term. This is the r plus 1 factorial minus 2r r into r factorial minus summation r into r factorial. Just split this and separate this one. So this would be what? The summation r plus 1 factorial minus, this is as it is, minus summation of, this is the r plus 1 factorial minus r factorial. Just apply the n factorial formula. N factorial means n into n minus 1 dot 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 last element 3 to 1 ending with the 1. So here this would be what? This is the for r equal to 1 to 20. Just put this value here. So 21 into 21 factorial minus 1 minus 21 factorial minus 1. This would be what? 20 into 21 factorial. So this would be 22 factorial minus 2 into 21 factorial. So 22 factorial minus 2 into 21 factorial. B would be our correct answers. So go ahead, our last questions. That question number 5 is coming in JEE Main 2021. It says that the summation k 0 to 20 ck whole square is equal to what? This is another questions. I just put you a lemma that c0 square plus c1 square plus dot 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 plus cn square is equal to 2n factorial divided by n factorial whole square. We just discussed in your chapter summary class. So using this, you have to find the k 0 to 20 ck whole square. This is what? 20c6. So first term 20c0 plus 20c1 whole square plus dot dot plus last element 20c20 whole square. This would be what? 40 factorial. So here n is 20 by 20 factorial whole square. We just apply here this lemma. Just a formula we just call lemma. So after calculate, you would be get the 40 c20. So 40 c20 would be our answers. That option number C, 40 c20. So we just discuss here the 5 important questions, and I think after doing this problem you will be able to do all type of questions coming in JEE Main and Advanced Mathematics. Just pause this video and take a screenshot of another 5 important problems of the homework. So I think you just take a screenshot of, so you will cover here the 10 important questions, and after solving you just contact and solve this homework in anyone need the file on my YouTube material and the study lecture. Just mail without no hesitation with this ID catschrodingers1935@gmail.com. So last but not the least, thank you very much. Stay well and happy, and have a good day.